might have to move this camera.
Figures.
To me, they're the same thing.
Figures. All right, my head up the last video.
Okay, so let's chit chat. So listen to me, listen to me, listen to me. What is the only time you induce a current? If there's a magnetic field,
And it changes.
or if the magnetic field is changing. Connor asks, when do you induce a current? When there's a magnetic field, or when the magnetic field is changing?
Can you ask the question again? I said whirlwind too many times.
This is not. When do you induce a current?
Yes.
When there's a when there's a current, when do you induce a current? When there's a magnetic field, or when the magnetic field is changing?
When it's changing.
Okay. A magnetic field in and of itself does not induce a current. Okay? So here's this loop. This is this question on the back, that last question. Okay? So here's this thing moving in, right? So it's going to experience, as that moves in, once it crosses that threshold and goes into the magnetic field, what's it going to experience? An increase in what?
X's.
X's. So what's it going to do to balance that? It's going to make O's to balance the increase of X's. Okay? So once that crosses, and you're into this portion of it, right? So focus on the leading edge of the wire, because that's where the current's going to be induced. So, and you're going to make it on the, and visualize it like you're making it on the left side of the wire. So, quit being annoying. So if that's the case, which direction is the current going to move in the front edge of that wire? Up or down? Conrad, you vote up. Gladiator thing, okay? Everybody up. Gladiator lives. So, the current is going to be moving
Oh, it's going this way.
up.
Mandated reporter joke, you can't see it, sorry.
Now you need to use the right hand rule a second time. So now that the current is going up and the external field is going into the page, what's the direction of the force acting on the card? To the left, which is going to make it speed up or slow down. Slow down. You're never going to make something speed up, okay? It is only going to slow down. If you ever use the right-hand rule with this, it's technically called an eddy current, and you get it where it's speeding up, you have done something wrong, okay? This is why it's commonly referred to as magnetic braking. It's never magnetic speeding up, okay? Just saying. And sometimes they'll even use this like on a roller coaster. For a braking deal, what they do on the bottom of the roller coaster, they'll have like an aluminum plate, and then in the track, they'll have a series of like strong magnets. So then as that aluminum plate goes through in between the magnets, it creates an eddy current, which makes the roller coaster slow down. So it's an easy way to have some braking. And when I ask you, like, on that explanation, just don't say, oh, because of the right-hand rule.
What? I don't understand it any deeper than that, though, Bert.
What are you trying to make?
O's.
O's.
O.
Why?
More X. Balance.
That's how you need to explain it. Okay, just don't say, by the right-hand rule.
Isn't that like?
That's like saying,
The right-hand
why
rule?
did you jack up the experiment? Oh, human error. No. Don't get me wrong, that might be valid, okay?
Well,
Don't get me wrong.
We just break
You just suck in.
We just break.
Both of your answers on part
we
B
just play one.
should be less than 1.
Good, good, good. It can still be a lot of stuff.
That's an infinite number. Closer. I need a range, really, you could say.
They're multiples of each other, how about that?
Yeah, high five.
It's, okay, but it confirms what we have.
They're multiples of each other, like 2 and 4, 4 and 8, 12 and 24.
It can be.
Never mind. I don't even know what I'm talking about.
Then don't. Okay, now Connor S. asked a question.
Whoa, I just want to confirm, buddy. No, I knew what I was talking about.
I'm trying to use it as a learning moment, Connor S. So, once it's all in the magnetic field, then what's gonna happen?
Nothing.
Nothing. Why?
Magic.
Photons.
Photon.
The sun.
Oh, you dropped the
Gravity.
photon card.
Magnet.
It's always photons.
Always photons.
Even
Oh, wait
we're
until we get to the next
photons.
unit, then we'll deal with some serious photons.
Even
We
we're
got protons
photons.
and electrons. And
These are the joking photons?
Other electrons.
It's a tricky
And goes on.
now,
living.
once it's all in the field, nothing's gonna change. Is there a magnetic field? Yes. Is anything changing? No. But now, when it exits, what is it going to sense?
A decrease in X.
So then it's going to make,
Exit.
so that wasn't part of the story, but you need to have that. Yes, your answer to number 9 on page 2, where you're finding, the induced current, that should be a big number, okay? Now, but that's also over like a very small area. It isn't like we're gonna charge the entire aluminum plate to 600 amps, okay? There's a temporarily very, very, very small area that's gonna have a current on it. So like I've tried to like measure, I actually hooked up an ammeter and tried to measure it when it went through, and it got wonky. Anyway, so on number 7, the value of the opposing force, this is an ish, but it should be somewhere around 0.2. Okay? That's a huge ish, but it's somewhere around 0.2. Make sure that you have paid attention to signs. What's positive and what's negative. Okay? Make sure that you have paid attention to that. All right, any questions on the lab? Once, twice sold. Okay.
We did not get point 2. As I was saying, our data's weird.
Try to make it through.
You said around 0.2. Does it have to be 0.2?
This is a lot. This is not around point 2. This is a lot.
It makes me wonder. It makes me wonder if we measure
I just made a noise.
Mitchell, it makes me wonder if we measure that as well.
It's that vertical distance. Make sure when you're doing that calculation on that auxiliary question, only use the leading vertical edge of that wire, okay? Because the horizontal section isn't going to be impacted by anything. It's only that vertical edge. So when you're doing that calculation, that L value, only use the vertical distance of the point 1. Don't use anything else. It's only that distance that you need on that. Okay, cool, got it? Okay, so let's go. You don't need to bring the camera, but let's go to the back and I'll show you kind of a cool application of how this works. So